Hi there, welcome to the Green Living Chats. I'm your host, David, with EcoAmed Solutions. Today we bring you a special episode, Research Stories. This is where we have chats with researchers in diverse disciplines of the environment, talking about their researches and how they can be applied in the industry. So pick bits from it and use it for awareness campaign. Today's episode is part one of a three-part series with Dr. Daniel Fiifi Tawia Hagan. Over the past 10 years, Daniel has been conducting research in 3 system integration and meteorological applications in the Nanjing University of Information Science and Technology. Daniel is currently a postdoctoral fellow in the same university focusing on remote sensing and numerical modeling of land surface processes. Daniel has a rich experience in collaborating with key international research institutions, including the National Center for Atmospheric Research, the National Oceanic and Atmospheric Administration, and National Aeronautics and Space Administration in the US and other countries. Daniel has contributed to over 30 SCI publications both internationally and within China. Our discussion focuses on remote sensing, the benefits of remote sensing, and how remote sensing can be used to make predictions in climate change. His research focuses on soil moisture in the topsoil and as well as temperature changes in the atmosphere. We also dive into the variables, assumptions, and satellites used in remote sensing, as well as the fundamentals upon which his research was based on. Let's get into it. Hello, Daniel. Thank you for making time and being on Green Living Chats. We are so grateful that you're here. You're welcome, sir.
Thank you very much. Thank you very much, David. Thank you for having me. Yeah.
I think today is going to be a beautiful day because finally we have 2 Infansipan boys on the show. And
Yeah.
this is so good. Finally, I can talk to family.
Yeah.
And I want to say congratulations on your new position.
Thank you
Congratulations.
very much.
Yeah.
Yeah. Thank you.
Would you want to say a little bit about it?
Oh, this is definitely an exciting time to be doing research in China because China has a lot of resources to support research. So I'm very happy for the opportunity that I have. Yeah, definitely.
Yeah, that's great. All right, so let's dive straight into your research.
Sure.
I have read a couple of your papers, and I mean a lot of people within the China community, they know you for remote sensing and a lot of the good work that you're doing in this area. Your topic seems very interesting, and I think that there should be a story behind this whole thing. How did you get to, and how did you come by this topic?
Oh yeah, there's a lot of indirect stories leading to that.
Exactly.
uh, well, I'll just as I was thinking over this, there's just two of them that sort of highlight everything out. So I guess the very first one is that uh, when I was at I was at Tech, Kwame Nkrumah University of Science and Technology in Ghana. I did a 1 year program there, and I mean, I had been crazy about satellite technology before I even went to Tech. I, I used to take my Sundays, Sunday afternoons to just watch Discovery Channel or something like that, and and have interactions with my dad on it. And so we're both kind of like nerds on these things, and like trying to watch these things. But I never actually dreamed that I would have the chance to work with these things. This is kind of a dream that it's a dream in the heart, but definitely a dream come true for me. But I guess that in my first class at Tech, the lecturer he made a comment about satellite technology, and he said, very few people know about this technology and really know how to use it. And I had always been sort of raised to try to go to places where few people are. So I loved the talk that he gave when he talked about what we can use these things for, and I just got so crazy about it that when I got a chance to come to China, I just took it. So I had been learning about these remote sensing technologies. So the idea of remote sensing means that you are measuring something without touching it. That's kind of remote sensing. So you are sensing it without touching it. So it's a remotely sensed measurement. And so this whole idea has to come from measuring the earth, and or measuring even people. So when you take a simple photo, is if you take your camera and you take a photo, it's actually remote sensing, because you measure the person, you kind of get their outline and their measurement without touching them. So it's interaction of waves, and so this on a larger scale, then we have this sort of satellite remote sensing technology, and so I got very, very interested in it. But more so when I was finishing up my undergrad, I started reading papers because I was trying to do some research. I was really learning to do research at that time, and I read a paper and I saw a particular line that we still don't understand the significant role of soil moisture in the climate. And I was like, wow, okay, this is a good sentence for me. I mean, for me, that was a that was a lie. Like, this is where I'm supposed to go. So I started sort of reading on soil moisture and all that. And soil moisture is, I would say, generally defined as the amount of water in the soil. Um, uh, and so in 2013, I attended a conference in Beijing, an international conference in Beijing, and we had this guy from the Netherlands who is part of the committee of the Nobel Prize, and he himself has Nobel level awards, and he started talking about soil moisture, and I got super excited about it, and and to top it up, he sort of combined soil moisture and how we can use remote sensing to really measure soil moisture. And I felt like this was definitely an area I wanted to go to. So I spoke with him after the conference, asked me if it was possible to ask him questions and all that. And he couldn't answer one of my questions. And he said, there is actually a guy, a Chinese man who worked on this thing in my group in the Netherlands. And he just came to China. You can look him up. So he tells me the guy's name. I look the guy up and find out that he's actually in my university.
Oh.
So when I went back to my university, I sent him an email, which he didn't reply. But then, so fast forward, I was having a chat with my undergrad supervisor, and I told him about soil moisture. And he said, this is a very difficult topic, and he doesn't know it very well. But I said, but a friend of mine just came from the Netherlands, and he's a big guy. He worked with a very big guy, so I can introduce you to him. And I said, wait, is his name blah blah blah? He said, yes. Do you know him? I'm like,
It just
well,
worked out.
someone told me about him. Like that was like 6 months later, and then he booked a meeting. The next week, I was with the professor in his office. We were having chats, and then the professor actually said, "Wait, did you send me an email 6 months ago?" Apparently, he saw the email. But anyway, the guy said, he was like, "So what are your plans after graduation, bachelor graduation?" And I said, "Well, I'm applying. I was applying to Norway at that time. There's a very good school in Norway I wanted to go to." He said, "You won't get to do research in Europe as a master's student." So he said, "But if you stay here, I'll take you on." And I said, "Okay, let me do my research and see." So I contacted the school in Norway. I asked them, they said, "No, you don't get to do any research." Now, I felt that was boring. Yeah, like, then I don't even want to do the graduate program.
Exactly.
So, yeah, so then I went straight to the guy. His name is Goje. I went to him, and Goje and I have been friends since 2014.
Wow.
And he's been my supervisor, and so he has been working in this, and he knows a lot of people who work in that, including one of the leading companies in the world, because the guys who set up the company are from his lab in the Netherlands. So I got to work with them, and we've been working with satellite remote sensing ever since. But there's another part of my thesis that people don't usually pay attention to, which is actually the part I'm more interested in. But it's the part that people don't like because very, very, very few people, actually, very, very few people are working on that. That is called causality,
Okay.
causality analysis.
You want
So
to explain that?
yeah, so essentially it's kind of like what causes what. So if you see flood happening, what is causing the flood? It seems like a very general idea, but it's actually probably the oldest idea in the world. Because we're thinking about, okay, why are we here and all that. You're thinking about cause and effect. You do something and then something happens. Newton's third law. Every action has an equal and opposite reaction. And so this, for me, I've been crazy about Newton's third law for a long time, since I heard about it in high school, and I've really been thinking about it. So I'm crazy about movies that have to do with time travel, all these things. So bathtub, time machine, what Avengers Endgame, because they traveled in
Okay.
time.
Yes.
Like Back to the Future. This kind of
Mm-hmm.
I'm crazy about these movies, because of the manipulation of time. So I've been learning a lot about time, both in philosophy and physics, and the whole concept of time is has been a fascination for me. So I one of my friends, my Chinese friends in my school, told me that my professor is his professor was working in this area, and his professor was one of the leading guys. Well, if probably the lead guy himself in the world,
Mm-hmm.
uh, in this field of causality. And he's like, I can introduce you to him. So
Beautiful.
I went to meet the guy. He had just come from NYU and Harvard,
Mm-hmm.
because he graduated from there and was working there. And so he called me. He said, Daniel, I've been told about you. And then he told me that if you work with me, we can talk about time. And so I definitely wanted to work with him, because the idea of using soil moisture, and the impact of understanding soil moisture is very important in the community, which is that soil moisture can help us to understand how droughts occur, how heat
Okay.
waves occur, how floods occur. Definitely, soil moisture will impact agriculture, food, water, drinking water, aquatic life. And so it's definitely an important variable. But our ability to predict the changes in the soil moisture is actually more important, because if we can forecast that this is what is going to happen to the soil moisture in, say, the next future, in near future or something like that, then it's going to be important. But how do we do that prediction? It's a cause effect relationship. What are we doing now that is going to cause a kind of effect in the future? And this is where causality analysis comes.
Mm.
And so I worked with this guy. I've been working with him since 2014 till now. We are working on causality ideas. And so this is kind of my story, the two stories of how remote sensing and soil moisture and causality came to sort of be one story in my life. And that's what my thesis was about. And yeah, but people don't really like to pay attention to the second part.
All right. Today we'll talk about it.
Definitely, yeah. So this is kind of the whole idea of my story, my research, and the motivation is that I like to think about the food, water, energy nexus, and to see if I can make any contribution there. I read a report by uh, which was it was written well, it was written to the government of the United States. It's the title is Prediction and Predictability, and and this sort of this report is one of the ones that got me hardcore into this field, and I think that it's one of what I found was that there are very very few people on that board working on this idea, and so I like the idea that by getting there I can make a significant contribution there, and yeah, thank God that I have someone who
Yeah.
he's actually the chair, the the global chair of this committee, and so I'm really happy I get to work with him and to think about these problems with him. Yeah, so this is my story.
This is
Yeah.
getting interesting by the minute. I'm getting so soaked in this story, and I don't know, just a lot of questions are running through my mind, but I just still have to
Yeah.
stick to what I've written. Yeah, so let's dive into your research specifically,
Okay.
and after we're going to tap a lot of things from your experience and questions that has to do with
Mm.
getting into sustainability and climate change and all that. So with your
Okay.
research, I know that you have done a series of researches.
Yeah.
I mean, over the years. So I don't know which one you're
Yeah.
going to pick point to talk about, but maybe we can just choose a
Yeah.
recent one, or probably maybe any of them that you want to choose. Uh,
Yeah.
what variables do you consider? Because I know you use
Okay.
models to predict these, to make these assessments and all
Yeah.
that. It's very important
Yeah.
that we know that over the years, there are so many things that are happening, and activities of human activities are changing by the day. We have we have industrial revolution, so many things are happening. And so
Yeah.
what are some of the things that you consider to be able to change the variables to, so that these variables look like the actual things that are happening? I'm very interested about this.
Okay. So the unfortunately the boring part about my work is that I I prefer to tackle fundamental problems,
Okay.
and the thing is that because of that, I tackle the fundamental problems and sort of uh, develop ideas that people would use for applications. Applications are definitely important, and they definitely validate what you have done at the fundamental level. Um, but I find that a lot of people prefer to do application, and very few people prefer to do um, like to do fundamental things. And so I like to go into fundamental topics because then contributions are significant, and it's still this whole cause effect thing over there. So I'll probably start with the remote sensing. So remote sensing technology really is very helpful. I'll try to give a simple example.
Yes.
If if say you want to measure the temperature of say let's say our country Ghana, you want to measure temperature over Ghana. So what the Ghana Meteorology Agency has done is that they have these um, gadgets that do the measuring, and they have so when they set up a gadget, it's called a station, and they have 22 of these stations throughout the country. At least as far as I knew from the last time I spoke to them. So if you have these 22 gadgets throughout Ghana, and Ghana is a huge place. I
Mm-hmm.
mean, it is a huge place. But imagine that you have only 22 points.
Across the
Trying
nation.
to exactly, trying to pick up, different uh, temperature readings, that is definitely not enough. It's not even close to being enough for, say, I don't know, even one high school, because um, the most ideal situation would be that you'd probably have them say at most 1 meter apart, but this is where you have them kilometers apart. And so then the question is, what do you do with the with the distance in between them? How are we going to account for the readings in between them? And China has more than 3,000 stations, you know, and but even that is still not enough. It's really not enough. You still have to account for in between these things. And there's a very comprehensive station over the Tibetan plateau. That is kind of like they have a lot of stations, and they've and everything is like put together in one small area, because they want to do a very intensive reading. But even that still sometimes is not
Not
enough.
enough.
So then the idea is that once you begin to these stations are good when you're talking about localized sort of you're looking at small areas, small areas, they can be helpful. But once you start blowing up the image and going wider, then you have a problem. So over global scales, then you really have a very big problem. And so remote sensing technology, where we have satellites launched into space and are measuring the Earth, then you sort of have a bigger view. So the satellites are able to measure,
Wider
but
view.
even that wider view, they're just going round, some of them are either going round, okay, and some of them are stationary, they don't move, so they're at one point, they're sort of they are revolving with the Earth, okay, but okay, they are revolving with the Earth, or maybe rotating with the Earth, something like that. So they are moving. Then the Earth's gravitational pull is keeping them in orbit. And so one of the cool things we can do with this is that we can measure larger areas. We can have finer readings. Okay, so then you can have readings over the whole of Ghana or China or Africa or something like that. And so what these satellites are doing is that every object in space gives off energy. Okay, we call it emission. And so this energy is picked up by the satellites. Okay, it's picked up by the satellites. It's either the satellite throws energy and receives the bounce back energy, or that the satellites actually just stays there and receives the naturally emitting energy, because every object is in vibration. And it's the same thing with like the Hubble telescope or something like that. It just picks up emissions from other places. And so what I have been doing is that quite a while ago, some guys at NASA figured out that when the satellites pick up the images, there's information of the different land features. So it can even be a house or a car or something like that. But of the land itself, there's information of how much water can be in the topsoil, or what is the temperature of the land. And so this information can be translated. And when we translate them, we call them retrievals. Okay, you retrieve the information from the images. And so what I do is that I have been focusing on three parameters.
Okay.
Three parameters. So the first one, of course, is the most basic and important one, which is the temperature of the land surface. So we call it the land surface temperature. And then we have the temperature of not temperature, but the amount of water in the vegetation. And then the amount of water in the topsoil. And I emphasize topsoil here because the satellite's penetration into the land is very, very small. So yeah, it can go, at least the satellite that I use, which are called passive microwave satellite images, they don't penetrate more than 10 centimeters.
Okay.
They don't penetrate more than 10 centimeters is actually too much. So they go between 1 millimeter and maybe at most 5 centimeters, something like that. But then it still gives us some very useful information about the topsoil, because the topsoil is the most variable. The topsoil features are the most variable because they are between the atmosphere, the overlaying atmosphere, and the land itself. And so both the atmosphere and the land are working on them. Sort of there's an interaction going on. So it's very, very variable, and it can change. And the changes there will bring about, heat or water or something. So I'm not sure. When you go on my ResearchGate, for instance, we just published a paper with the American Meteorological Society, observed linkage between the Tibetan soil moisture, Tibetan plateau soil moisture, and South Asian monsoon.
Yeah, I'm looking at it right now.
Okay, so I think the full paper is not yet out, but at least you can see the abstract over there, something like that. So that is a paper that I supervised one PhD student in our group to do, where we were using remote sensing technology to measure the soil moisture over the Tibetan plateau, and to see how that is able to change the rainfall pattern over South Asia, which we found a very strong link, that soil moisture is able to change the rainfall pattern. So if if soil moisture changes and then this thing, the rainfall also change, which means that the human impact on soil moisture will also impact the rainfall, will
Exactly.
impact drought, will impact floods, and all these things. And so this is a very, very important variable, and I really, really like these variables. And the satellites that I'm using, or the satellite images that I'm using, they are able to penetrate through clouds,
Okay.
which is usually a problem. So if you are familiar with basic science, you know that we have the wave spectrum,
Mm-hmm.
right? We have the wave spectrum, and so there are different waves, and I focus on the infrared and microwave,
Okay.
but more on the microwaves. And in the microwaves, because the microwaves are very natural and they can penetrate through clouds.
Yeah.
Infrared cannot penetrate
Through
to clouds,
clouds.
which means that if you have a very cloudy day and you are using an infrared imager, you can't you don't get any information on the land. The clouds will sort of block everything. But if you have a passive microwave imager, all the all the waves coming from the earth will penetrate through the
Through the
clouds
clouds
and
and to
you still
receive
get
it.
information. Yeah, so that is definitely a promising field, and there are a few people working on it, and so I was very happy to be part of it. So the technicality of my work or my research was that um, we make some assumptions in in the retrievals of the soil moisture, land surface temperature, and vegetation. We make assumptions, and these assumptions would definitely reduce the quality of the product, the quality of the data sets that we have. So of course, if you make an assumption, then 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 you lose information,
Exactly.
because so but sometimes the assumptions are necessary because we have to get the work done. So in my thesis, I was I was looking at an assumption that was made somewhere in 2009 by one guy who I'm currently working with. He's at NASA Goddard, and so the assumptions that he made, I sort of took that assumption and tried to quantify that assumption. That okay, now let's not make that assumption.
Okay.
Now let's see what happens. Are we going to get better products? And I found out that my when we don't consider the assumption, we can actually improve the quality of the data sets that we get from the satellite. So that was one of the big things about my thesis, which was advancing the improvement of soil moisture estimation from satellites and land models.
Okay.
So we were able to improve that, which is quite interestingly during my thesis defense. During my thesis defense, we had someone from the China uh, Geographical Institute or some Geographic Institute, and he was like, "Hey, this is what we just got a project to do this." I'm like, well, it's done. Just use our data, So yeah, so I am working on the. We have this series of satellites. China has a lot of satellites.
Yes.
So we have this series of satellites called the Fengyun satellites,
Okay.
and the Fengyun satellites, like A, B, C, D, E.
Ah, now
I don't know if
it's
there's
all
F.
making sense. I see all those
Yeah.
phrases in your papers, and I was wondering.
Aha. Okay. So yeah, I have been focusing on using the three Fengyun 3B, and the three. So I have been using the Fengyun 3 series. So the 3A is one that I doesn't have what I need, but 3B, 3C, 3D, they have what I need. They have passive microwave images, kind of like cameras.
Yeah.
So they have those cameras on board, and so I can use the observations that come from them. So my teacher had a project with the China Satellite Meteorology Center, and I've been working on this series, um, and complementing that with NASA's satellites
Mm.
and the satellite from Japan Space Agency, which is called JASA,
Mm-hmm.
and then also from the European Space Agency ESA. So sort of put all these products together, because every satellite has its own limitations. So yeah, so we try to put it together. So I have been focusing on the Chinese satellites and improving the quality of the Chinese satellites as well as the algorithms, and so that people can use it. And I've actually I just finished working on a long-term data set for China for global soil moisture, which is on zenodo.com. Anyone can just go and download it. It's been uploaded. Anyone can just go and download and make use of it. And yeah, so this is what I've been doing. And definitely in my thesis, I considered two problems. I found out that we have a problem of data sets, reliable data, and also to find a robust method to help us with our prediction.
Okay.
So it's not enough for me. It's not enough to just have the data. You want to use the data to do the prediction. But then the prediction models are also problematic. And I'm very happy with this platform because I want to use this platform to talk about a certain bad practice, which is that people usually rely on correlation analysis to do prediction, which is very, very wrong. It's wrong because correlation methods, well, maybe in applied mathematics we call them, they are symmetric. Symmetric means that if you are looking at the correlation between David and Daniel, when you apply correlation analysis, you can't tell whether what you are measuring is what is the cause from Daniel to David, or it is from David to Daniel. Correlation cannot separate them. So in correlation, we don't have the direction. So, all you can say is that they may have some relationship, but you can't infer direction. But people have been really using that to suggest directions, which is very, very meaningless. And so one of the things that I did was that with my other teacher, the mathematician, we looked at developing a model that can infer direction, so that, okay, if you're looking at the cause effect between A and B, is A causing B or B causing A? For instance, in our recent paper, is it really soil moisture that is impacting the monsoon, or is it that the monsoon is rather impacting the soil moisture? With correlation analysis, you don't know the direction, but with causality, you find out that the direction is very clear. And so you need something which is asymmetric. Asymmetric means that it can bend towards one direction or another direction. And so my teacher, that particular teacher, he had been working on something called information flow theory, and information flow theory has this asymmetric property. And so he developed this model, which was very good for it. But the model, of course, had an assumption. So
there we go.
And so that assumption is not good when we apply it to soil moisture. So in my thesis, I attempt to remedy that assumption by sort of removing it and facing the problem and improving the model. So last year we submitted a paper for that, and it had a very good response from the community as well. And so these are two fundamental problems that I've been working on: how to improve the reliability of the data sets that we get, and to improve the prediction models that we are using. So I have been working on the fundamental parts and looking forward to people using these ideas to do it. But certainly, it's something that shows a lot of promise. I did some case studies, and I found out that soil moisture can actually change the temperature, the state of the temperature. So in 2003, for instance, there was a heat wave over Europe, which killed a lot of people. It killed a lot of people. And so we found out that one of the things that was really, really causing this heat wave was soil moisture, changes in the soil moisture. And so in this case, it means that we can predict what will happen in the future if soil moisture is to get to that level again. And we can tell, okay, because the soil moisture is going to be like this, there's going to be a heat wave. People should stay indoors. They shouldn't go out. And yeah, and so of course we haven't yet quantified so much how human activities impact soil moisture changes. It's a very difficult question
Yeah.
because it is difficult to quantify anthropogenic activities, human activities, you know, but it's definitely one of the things that the UN is very interested in, and we are certainly working on that. I'm not sure if you are familiar with the IPCC report, the Intergovernmental Panel for Climate Change. So this
Yeah.
is they release a report every number of years, and this year, for instance, the next report, my group was the one that was handling the soil moisture report over China. So we submitted the soil moisture report over China, and during that report, we actually forecast 100 years into the future to see the state of these variables and how they're going to impact life in the future. And so it's a very exciting.
Yes, it is. Very.
Yeah, definitely. Yeah.
Thank you for listening to today's episode with Dr. Daniel Fiifi Hagan. In part 2 of this series, we're going to discuss into details assumptions used in remote sensing. We're also going to discuss the impact of human activities on temperature changes as well as CO2 generations and the relation between them, and how we can use that to forecast heat waves as well as the gap between researchers and implementers. See you again on the next episode. Until then, live green.